Hello, everyone, and welcome to this short discussion where we discuss some research articles on mathematics and physics, which often are not really discussed in the rest of communications on science. So, today, what I want to discuss is essentially some statistical assumption which is made in the so-called evidence-based medicine, and how this particular assumption may have led us, let's say, astray for quite a few decades, and how this basically can be very, very important indeed. So just to put a little bit of context, in a previous video, which is going to appear somewhere here, I actually discussed a particular issue that came about in toward the end of the 19th century, when people started discussing probability laws, or formulating, I should say, natural laws by using probabilities. And these very same people starting to wonder, how do we justify this? How do we justify the use of probability laws to explain nature? One of the explanations and assumptions that they made is that there is an equivalence or an equality between the statistics of the fluctuations of a variable over time, and the statistics of the fluctuations of a variable in a collection of copies of that system at the very same time. Okay, and if this particular assumption or properties basically is met, that time statistics is the same as cohort, if you will, or collection statistics, then the system is called ergodic. And what we had seen in this video is that actually ergodicity is not that easily met, and in fact, that's an open problem in the hard sciences. Okay. Now, as it turns out, in the 20th century, there's been great many developments in statistics and their use to inform medical practice. And overall, nowadays, this is called evidence-based medicine, and this is considered to be essentially the top of the pyramid of how to deal with data in science. Now, one of the issues with this is that it's taken, let's say, for granted as being the best thing you can do, and it's difficult to determine how this particular um, methodological doctrine is actually challenged. And as it turns out, it can be, at the very least, intellectually challenged, and that's what this particular paper is doing. So the first thing that they highlight is so first of all, let me read the kind of the title. So lack of group to individual generalizability is a threat, so they don't mince their words, to human subjects research. This is published in PNAS in 2018. PNAS is like proceeding of the National Academy of Science in the US. It's a very, very reputable journal, and then we are going to see what they say. And in fact, from the very first line, what you see is that what happens is that in current practice in medical statistics, essentially ergodicity is assumed. Okay, is assumed in order to make inferences from the typical large cohort analysis that studies propose. Let's say randomized control trials propose, and then you need to make an inference from the cohort onto an individual. And usually, what they do is that they simply assume that this is the case, and it may not be the case basically in practice. So, just very quickly, so one of the things that they say is, and that is significant, so that's in this paragraph here, they need to explain the significance of this, is that basically, if what they say is correct, this may substantially alter best practice guideline in the medical and behavioral science. And the reason why is because what people do in practice is that they have this aggregate data from cohorts. Sometimes there is always a matter kind of time if you do, let's say, a procedure or some kind of drug. that is taken, let's say, on a regular basis over time, there is also a time component to it. And you want to know actually how this time component is can be analyzed independently from the cohort one. But usually in practice, they kind of put together in some kind of mixed fashion, and then it's difficult to tell what's going on. So one of the things that they flag as well, so let me check, so that's here, sorry, is that here, the consequences of, let me highlight this, the consequences of neglecting ergodic theory in social, behavioral, and medical field may have substantial epistemic and practical consequences. In the absence of quantitative examination at the individual level, the consequences could run from zero, if we are lucky, to catastrophic if a process is quite non-ergodic. Okay, so that's really what they say. And they mention above, so sorry, I need to come up a little bit here, that one of the typical paradoxes, especially in medicine, is called Simpson paradox, whereby for a small group you would observe a particular, let's say, upper trend, let's say for a given correlation or something. And then if you look over a larger cohort size or a larger range of values, then you're going to observe actually a global downward trend, for example. And this particular thing can be explained, in fact, by a lack of ergodicity. So what do they do in practice? Well, that's explained here. They actually look at 6 previously published data sets. I'm not going to go into any of the details. If you want to read the article, it will be in the description of the video. But the bottom line is that they take 6 data sets that contain both cohort and longitudinal data. So they are not looking just at the data for like the global data for the cohort. They are looking at time for every single patient or for every single participant. So what do they do? They actually have this data, and then they can actually look at the data over time, so the fluctuations and variations over time for a single individual, and then they look at the aggregate measure of that. And then they also do the same, where they actually look at fluctuations and variations over the cohort, and then they look at how that varies over time. And what they actually get is summarized in a table here. You don't need to read kind of all of it. Essentially, this is related to some of the variables they were looking at in the 6 studies. So here, this was a study on depression. And so, for example, they had a scale to measure the level of depression of each kind of patient over time, blah, blah, blah. And what you see is that the mean for the intra-individual is, so within the single person, what you're going to find is 30.59, which is not too different from what you would find, for the mean in the cohort. Okay, so that's fair enough. And that's kind of maybe a little bit expected, not necessarily, but that's fair enough. However, if you look at the standard deviation, so SD stands for standard deviation, so essentially is the how do you deviate from the mean, that's kind of what it means. Then the intra-individual, so that the over time for a single individual, you would find a standard deviation of 22.01, while for the cohort, you would find 2.77. Okay, so there's almost a factor 10, actually, if you look, there's almost a factor 10, let's say from 5 to 10, for the different variables people look at. So that's really kind of something. So just to make it more visually kind of appealing, here this is for the correlation value between 2 particular variables. So here, for example, they was trying to look at whether the depressed mood was correlated with anhedonia, which simply means kind of lack of pleasure sensation. And so what you see here is that the actual intra-individual variation is huge compared to the cohort one. Okay, and so clearly these things are not the same. And by the way, here in that case, the mean is completely different from in both cases as well. Okay, so what you see is that if you were to make, imagine a diagnosis or a particular medical recommendation or procedure based on this data, you are far off when you actually consider a single individual that has this huge variation here. Okay, so the bottom line, I'm going to stop here, is really that there are reasons, and I'm going to go back to the title here, to actually be cautious about in fact, any claim that is made using any of these kind of randomized control trial data, aggregate measures from epidemiology, such as person year kind of terminology, and so on. All of these are predicated upon the fact that the processes or variables we look at are ergodic. And this is absolutely not clear that this is the case, because this was essentially ignored for most of the almost kind of 120 years that these kind of statistical tools have been used in medicine. So I think it's time to actually use them, and this is a very, very heavy blow on this kind of statistical analysis that needs to be discussed more. So if you've got any comments or questions on this, by all means, do let me know in the comment section, and otherwise, see you in the next video.